Hello and welcome back to the Linux Panic YouTube channel. In this video we'll be going over Linux from Scratch Part 4 in a Linux from Scratch System D series. But first, don't forget to hit the like and subscribe button and give that notification bell a good old ring so you don't miss out on any future videos. So first off, make sure you have a drink. In my case it is 20 fluid ounces of coffee or 591 milliliters for anyone non-American. So what we're going to be doing is moving on from chapter 6, cross-compiling temporary tools. This is what we did in the last video, part 3. I'll stick a card for it up here now. So what we can do is wait for this to catch up, because last time I looked at this date's wrong, which means I now need to go correct it, because I have just fired the virtual machine straight back up, and Ubuntu's going to throw a hissy fit at me if I don't correct the date in time. There we go. There we go. Okay, so what we need to do is we need to go up, down to GCC, onto chapter 7, entering chroot and building additional temporary tools. So, in this chapter, it shows us how to build last missing bits of the temporary system, the tools needed to build the machinery or the various packages. Now that all circular dependencies have been resolved, a chroot environment, completely isolated from the host operating system, in this case the live ISO, except for the running kernel, can be used for the build. For proper operation on the isolated environment, some communication with the running kernel must be established. This can be done through a so-called virtual kernel file systems, which must be mounted when entering the chroot environment. You may want to check that they are mounted by issuing a find mount. Until section 7.4, entering the chroot environment, the commands must be run as root with the LFS variable set. After entering chroot, all commands are run as root, unfortunately without access to the OS on your computer you built LFS on. Be careful anyway, as it's easy to destroy the whole LFS system with badly formed commands. So, what we must do here is go into root environment. So we need to do control. So the first thing we need to do is back down to, so we need to do cd $LFS, remount LFS, cd into sources, do rm-r, gcc, the directory, yes. Right, so we're currently in sources. Now we need to do control D. We're currently back in root, and we're still, so we want to do cd and then cd into LFS. We're currently in LFS, cd into sources. Currently in the correct place. So, if I've got this correct, so let's just cd back down to LFS, cd into the LFS, and then echo LFS. We're currently, LFS variable is set. This is what we want. So what we need to do is change the ownership of the LFS directories to the user root by running the following command, which is this. So it's just going to change everything. Come on, mouse, pick up. Come on, mouse, you'll catch up any day. Place this in, hit enter. No output is good output. Remember this. So what we need to do is the various file systems exported by the kernel are used to communicate to and from the kernel. These file systems are virtual in that no disk space is used for them. So this is, and the content of the file systems are kept in RAM. So this is important. So first thing we need to do is do make pv at LFS dev proxys and run. Hit enter. The directories are created. Dev proxys and run. Dev proxys and run. This is what we want. When the kernel boots the system, it requires the presence of a few device nodes, in particular console and null devices. The device nodes must be created on the hard disk, so they're available to before the kernel populates in /dev, or before it populates dev. Additionally, when Linux is started with init bash bin, initialize bash bin, create the devices by running the following commands. So we're going to do make node. Enter. Remember, no output is good output when it comes to making directories. So we have both our console and our null. So now we need to mount and populate dev. So to do that, we just copy it and again paste. And as we can see here, dev bound mounted dev bound on mount lfs dev. This is what we want because it's telling us to do that. The recommended method of populating the dev directory with devices is to mount the virtual file system, such as tempfs, on the dev directory and allow the devices to be created dynamically on that virtual file system as they're detected or accessed. Device creation is generally done during the boot process by udev. Since this new system does not yet have udev and has not yet been booted, it is necessary to mount and populate /dev manually. This is accomplished by bind mounting the host system's dev directory. A bind mount is a special type of mount that allows you to create a mirror of a directory or a mount point to some other location. Use the following commands to achieve this. So this is basically just raid striping. It's not raid striping. It's just raid. This is saying, hey, look, copy from here to here. That's all it is. So this would be RAID 5. So just copying what's there, which is fine. So now that we've mounted and bound dev to LFS dev, we need to mount the virtual kernel system. So we need to do these one at a time to make sure it all goes through. Remember, no output is good output, except in this case. It's saying dev PTS mounted to dev PTS, proc to proc. If it says it's mounted and nothing else, that means it's good. So we need to keep that in mind. And that is tempfs. So what we need to see is we need to see 4. So it's PTS proc sys and run, and we have PTS proc sys and run. In some host systems, the dev SHM is a symbolic link to run SHM. The run temp file system was mounted above, so in this case only a directory needs to be created, and we can do that just by copy pasting if my mouse wants to work. Again, when it comes to making file systems, unless it's mounting like it is here, no output is, say it with me now, good output. So now we need to enter the chroot environment. Now what we're going to do here is we're going to add in one extra little thing to make our lives just a little bit easier. So what we're going to do is we're going to add a make flag into this so that the chroot environment it's going to say, hey, look, use these calls in the process so you don't actually end up wasting your time. So what we're going to do is we're going to copy all of this, paste this in, hit enter on. Well, in this case we couldn't because we went further back, but in the case we were doing this by hand, what we would do is we would hit enter after path user bin user sbin, and then do make flags in all caps equals apostrophe minus J4 apostrophe. Now that would be using the threads, but in this it's just using no threads. Now you may notice here how it says I have no name. This is fine because we've not created a password file yet. We've not done any of the expected behaviors that comes with chroot. This is fine. This is totally normal. This is what we expected. It says note that the bash prompt will say I have no name because, again, no password file. This is expected behavior. So now we need to create the full structure in the LFS system, create some root levels that are not limited, set required in previous chapters. So what we need to do is just, again, copy this. But first off, let's just cd into sources. So cd $LFS. So we're currently in, so let's just do print working directory. So this is fine. I appear to have made a small mistake, so I need to do Control D, cd sources, and run this again. Hit enter, print working directory. This is fine because I'm currently cd'd into sources, so we can continue on from here. So first off, we need to do is just copy the make directories. So we need to make the directory boot home mount opt and serve, as we can see here, boot home mount opt and serve. Now what I'm going to do here is do Control XE, Emacs command not found. So in this scenario, that would just allow us to just put all of this into one file and execute it one by one. But in this case, we need to execute all of these one by one at a time to make sure everything's done. So it says create a directory. This is what we want. We want it to say it's created a directory. Because in this scenario, an output is a good output. Done that. Nope. Done that. Create the required set of subdirectories below the root level by issuing the following commands, which is that. So we've just done bin lib sbin. So now we need to copy this, paste that in there, copy this. So as we can see here, we did previously color dict doc local man. So that. So now we're on to this one. So let's create 8 man directories. Now we're currently on to the cache and the mail spool. So if, for example, you've deleted a user in the past on Ubuntu, for example, and it says, hey, look, there's a mail spool here left over. Enjoy trying to make a new user with the same name. I know that's happened to me. That's happened to me many times, unfortunately. So copy this, paste this in, and now we need to create our links using link svsv. Paste this in, so it's just saying, hey, look, var run to run, and to do var lock to run lock, which is what we expected. Directories are by default created with permission 755, but this is not desirable for all directories. In commands above, 2 changes were made, one to the home directory of the user root, and the others to directories for temporary files. The first mode, in this case this, changes. The first mode changes ensures that not just anybody can enter the root directory, but at the same time, the same as any normal user would be able to do with his or her home directory. The second mode makes sure that the user can write to the temp and var temp directories, but cannot remove any other user's files. This is later prohibited by the so-called sticky bit, the highest being 1 in the 777. So what 777 means is literally anyone can change it. I should know. I used to run my own website with a 777 directory because for some reason I couldn't move files into it. It's just a whole shit show. So once we've completed chapter 7.5, we now need to move on to creating directories. Historically, Linux maintains the list of the mounted file systems in etc. etc mtab. Modern kernels maintain this list internally and exposes it to the user via the proc file system. To satisfy utilities that expect the presence of etc mtab, create the following symbolic link. We can do that by copying this, pasting this in. Again, this is fine. This is fine. Expect that I have no name because we've not created the password file yet. It's here. We're going to create it shortly. Create a basic hosts file, referencing some test suites and one of the configuration files for Perl. That's done. And now, in order for the user root to be able to log in and for the name roots to be recognized, there must be relevant entries in the etc password and etc groups files. Create the etc password files by running the following command. So this is what a usual password file would look like. If my mouse wants to function. Oh Lord, I need new mouse. Right, so copy this, paste it in, hit enter. We now have a passwords file. The actual password will be for root will be set later. Now we need to create the group file, and as we can see here, this is just going over the groups. And now we just copy this if my mouse wants to work. Make sure it's copied and hit paste. That is in. Create groups are not a part of any standard. The groups are decided on by the requirements of the UDEV. Configuration chapter 9. We're not chapter 9, we're currently chapter 7, so we can ignore all of this. Some tests in chapter 8 require a regular user. We add this user here and delete this count at the end of that chapter. So it's just a tester, but because it's a tester, we're going to copy it anyway in case you do decide to run any tests, or I decide to run any tests, but in this case we're not. To remove the I have no name prompt, start a new shell since the etc password and etc groups file have been created. So we're just going to do this, do that, and we have a root. Again, still in root. This is good. The login, getting init programs, and others use a number of log files to record information such as who logged into the system when. However, these programs won't write the log files if they don't already exist, so we just need to just need to copy. Just need to copy and paste these. Yep, I'm fighting with my mouse. My G502 is 5 years old, and this is its second attempt at dying on me, which is a shame. But hopefully I can click my way through this. It will be nice. Copy this, paste this in, and we're done. The var log wtmp files records all logins, logouts. The last log file records when each user last logged in. The fail log records failed logins, and the var log btmp records bad logins. Now, we need to, when building GCC Pass 2, we need to defer the installation of C++ standard library because no suitable compiler was able to compile it. We could not use the compiler built in that section because it is a native compiler and should not be used outside of the chroot and risks polluting libraries with the some host components. Lib standard C++ is part of the GCC sources, so we need to unpack it. So what we need to do is just cd lfs cd mnt. Now we need to do ls-la cd lfs. I was having a small moment here where I forgot that when we logged into chroot, the LFS, so how we see here, it's mount LFS. LFS became the root directory. That's what I was forgetting. So we're fine. We didn't do anything wrong, and we confirm this by doing ls-la, and that's what we want. That's exactly what we want. I was just having a slightly dumb moment, which is fine. So first off, we now need to do tar-extract with xf gcc. Now if we did xvf, that would do extract verbose verify, but in this case we're not. So now we need to do cd gcc. And once we're in here, we now need to do create a link which exists when building lib standard std++ in the GCC tree. So we just do that. Make our old friends the build directory and get into the build directory. As we can see, we're now in the build directory. Once again, you should know this one off by heart now. Create. Oh Lord. Oh my God, mouse. No. Set our config, hit enter. That's going to go through. It's just going to tell us what it's doing. Wait for the config. Now we need to compile it and then install. And again, this will take a little bit of time because it's saying 0.8 standard build units and 1.1 gigs of space. So this will take a little bit of time. I'm not going to bother with keeping the video running. I'll just start again once we're done with the make. So all I'm going to do is time curly bracket make semicolon curly bracket. I'll wait for that to finish and I'll be back once it's done. Okay, so now that we have done this, now we need to install the file library into our new system. To do that, just hit enter, and now that it's completed. So what we need to do is just cd .. Go back down to sources, rm-r, gcc, and we're done. So what we need to do now is move on to Gettext The Gettext package contains utilities for internationalization and localization. These allow programs to be compiled with native language support, enabling them to output messages in the user's native language. This is good. Now, you see how it says on these 280 megabytes per 1.6 build units? So it's going to build a lot. So what we need to do is we need to do tar-xf gettext cd into gettext, set our configuration up, copy, paste it in here, and then copy this. As what this is doing is we don't need to install any of the Gettext libraries at this time, therefore we don't need to build them, so it's just disabling the shared. It's going through here, putting verbose output, which is fine. Just gonna wait for this to finish, so whilst we do, we're just gonna have a quick sip of coffee. That's still hot, that's good. Oh, I wasn't expecting it to still be hot. The benefits of using a coffee flask. It's still hot. Right, so in this case, I'm not sure what's going to take longer. The configuration, well, the compiling information, compiling configuration. I swear I speak English. If you heard that, put compiling in the comments if you managed to make it this far. Holy Jesus, that was annoying. Anyway, once this is done, we'll just make the package and we'll go from here. Just gonna leave it a couple more seconds. If it's still carrying on, then I will stop the video and come back once we've made the package. I was not expecting, there we go. I wasn't expecting the configuration to take that long, so that threw me off. So what we're going to do is wrap it in a TypeScript time, make semicolon, curly bracket, hit enter, and we'll be back once this is done. Okay, now that we're back after this, it only took 2 minutes 52 seconds. I thought it was going to take significantly longer, but we did the make, and now what we need to do is we need to copy the message format, message firm, message merge, and text programs. We'll need to install it. Hit that. Is done. Move on to the next part. We're going to move on to Bison, so say it with me now. cd rm-r gettext, and now we need to come to Bison. So what we need to do is tar-xf Bison, cd into Bison. Again, our configuration, which I will be highly annoyed if my map. My God, what is wrong with my mouse? There we go. Jesus Christ. I would genuinely get the G502 Lightspeed if I could, but I don't think I can justify spending $120 minimum on a wireless mouse. But the only reason why I'd get the G502 wireless is because I have the G502 wired, and I like this mouse. It's a good mouse. It fits the hand. It's got the onboard memory, the ability to do a DPI change with a button. It's got programmables. It's got front. It's got forward and back. It's got DPI change. It's just an overall good mouse. If I could get another one, I would. But if I could get the wireless, I would. But I can't justify the cost. Anyway, now that we've done this, all we need to do is just wrap it in a. We'll make it in. For me, I'm going to wrap it in a time script. So what we're going to do is time space curly bracket space make semicolon space curly bracket again. Hit enter, and we will return once it's done. Okay, so once that's done, it only took 18 seconds, and now we need to install the package. So what we're going to do is just make install, watch it fly through, and it's done. So what we need to do now is cd rm-r Bison. Yes, move on. Now it's doing Perl. So Perl contains practical instruction and report language. So what we need to do now is do tar-xf xf perl dot tar.xz. Remember the tar.xz part. Copy the configuration without the mouse dying. I did not mean to open up the software. Oh, I didn't mean to open up Ubuntu software. Cry, as we now got to wait for that to finish. No. Try this again. And give me a second to figure out what's going on here. As we can see here, I've had a silly and I have forgotten to cd into the Perl directory because, again, I should have checked and I didn't. So if we try and run the configuration again, it's going to go through, fly through all of this. Yep. I can probably hear you going, Nick, you forgot to go into the Perl directory. This is fine. So what we're going to do is just going to wait for this to finish, and we'll come back once it's finished compiling. Okay, now that we have compiled, all we need to do is install it. So again, we'll wrap it in a time script. So we're going to do time, curly bracket, make, install, semicolon, curly bracket, enter. Now this will install our package for us. And we'll sit and wait. So it turns out we didn't need to sit and wait. I hope I didn't accidentally stop us at the recording. Let's just do a double check of that. Not that file. I need that file, like the Windows to catch back up. Okay, now we're good. So now that we've done that, we need to do cd rm-r perl. Yep. And then we need to move on to Python 3.1. So it is imperative here that you do this with the capital P, because this also comes with documentation as well. So if I just were to scroll down and find P, there's the documents for Python. It's important we do the capital P because the Python we want comes with the capital P. The documents come with a lowercase p. It is important you use the correct Python. It even mentions it here. So what we're going to do is we're going to do not rm-r, tar-xf Python. It picked it up immediately, which is what we want. cd into Python. Prepare for compilation. Copy this. Hope to hell it will paste in correctly. It will. Copy the configuration. Wait for the configuration to finish. In this case, the switch prevents the static installation of static library and disables Python package installer, which is not needed at this stage, which is fine. I will return when it comes to making the installing the package. Okay, now that we have compiled, it took a total of 2 minutes 22 seconds. Now we need to install the package. So again, we're wrapping this in a time script with time, curly bracket, make install semicolon space curly bracket. Now this is just moving from one to the other. This shouldn't take too long because it's only just moving from one to the other. So again, this looks like this may take a while, so I'm just going to, never mind, 13 seconds. So now, again, we're going to do cd sudo, not sudo, rm-r python. Yep. And now we're going to move on to Textinfo. Again, this is 0.2 standard build unit, so I shouldn't have to bother with faffing around with it. So what we're going to do is we're going to do tar-xf Textinfo cd into Textinfo. So we need to fix an issue. So we're going to copy it if my mouse decides it wants to work. Paste this in. Hit enter a couple times just to make sure. Prepare for compilation with compilation instructions. I swear if the compilation takes longer than the actual compiling of the package, I will cry. So now we just wait for compilation to finish. not compilation, the configuration to finish. And now what we're going to do is going to do time, curly bracket make, semicolon, curly bracket, hit enter, wait for this to finish. I'm probably going to have to turn up my AC again because it's starting to get really hot in here. So the audio will sound a little bit different. So I will return once I have installed the package. Okay, so now we're back. I'd like to apologize if you can hear the AC in the background. I don't really have much of a choice. If it got cold at night, it might be a different thing, but it doesn't. So now that we have installed a package, what we need to do is cd rm-r Textinfo directory and move on to Util-linux. So the FHS recommends that you recommends using var lib hwclock directory instead of the usual etc directory as the location for the adjust time file. We can create this with this. So what we're going to do is we're going to do tar-xf Util-linux. I just have to confirm that. cd into Util-linux. I'm just going to confirm this once I'll be with you in a second. So I'm back now. I was right when I said we need to copy and do it here inside the Util-linux directory. I just wanted to make 100% sure. Okay, we've done that. What we're going to do is we're going to copy the config and cry as our mouse refuses to work. Oh my dear Jesus. Copy this, paste it in, hit enter. Again, the config may take a little bit of time, so in the scenario that it does take a bit of time, I will return once it's time, after we've completed the installation of the package. Okay, in this case it's done, but we will just make and install the package. I'll return once the installation of the package is done. Okay, now that we have installed the package, as we can see here with the make install, this took us 2 seconds, and the compiling the package took 1 minute 27 seconds. We're now ready to move on. So what we can do is cd rm-r Util-linux and move up to the end of chapter 7, which is the cleaning up and saving on the temporary system. So what this does here is it gives us the option to back up what we have done. Because I'm only doing this in a virtual machine, I won't be backing up. So what we need to do is remove the currently installed documentation to prevent them from ending up in the final system. This will save us about 35 megabytes worth of space. So I'm just going to confirm where I need to be doing all of this because I want to give you the correct information. Okay, so because I'm not going to be making a backup, I don't need to follow from here down. So what we're going to do is we're just going to get rid of our documentation that we don't need. And we're going to do some extra cleaning up. By doing that, and we're going to remove the tools. So if you do want to make a backup of your system, I'd recommend that you follow the 7.14 section where it says do this if you want to, pay attention to it, but because I don't want to do that, we're not going to do that. So this is the end of part 4 where we come to the chapter 8. So what I'm going to do now is I'm going to thank you very much for watching. If you did make it this far, I'd like to thank you very much. I hope you've got something out of this. Anyway, it's been a good video. I'd like to thank you very much for watching. I have been Nick. You've been amazing. And I hope you have a good rest of your day. Goodbye.